Assalamu students, I am Sabir Hasnain, your physics subject teacher from grade 9. As you know, in last video lecture, we discussed about basic concepts regarding kinematics, in which we discuss about rest, motion, and later on we discuss different type of motion. Now in this lecture, we will discuss about scalar quantities, vector quantities, position, and later on we will discuss about uh, displacement and distance of a body. So let's start with scalars. Scalars are actually those quantities which have magnitudes, units. They are known as scalar quantities. For example, mass, time, distance, speed. These quantities are scalar quantities. They have only magnitude and unit. If look at the table, mass, let's suppose if I said my mass is 70 kilogram, it means 70 is the magnitude of my mass and kilogram is the unit of my mass. So it has no direction. If you ask me, you can ask me a question, sir, what is the direction of your mass? The answer would be no, there is no direction of your mass. So that's why it's a scalar quantity, time. If I ask you a question, what is the time duration of the physics class? Your answer will be the time duration of our class is about 40 minutes. So 40 is actually the magnitude of the quantity, which is time, and minutes is actually the unit of time. Later on, if I ask you, let's move 100 meters so in the ground, so 100 is actually the magnitude and meter is the unit of the term distance. That's what, because it has no direction. So the conclusion is all those quantities which have magnitudes and units only, those quantities are scalars. Now the second term, vectors. Vectors are such quantities which have magnitudes, units, and direction as well. They are called vector quantities. For example, displacement, velocity, acceleration, force, momentum, etc. Let's try to understand the concept about vector quantities through the example of force. If you throw a ball, definitely you will apply some force, then you can throw that ball in some direction, and that ball will move in specific direction. It either, let's suppose you throw a ball in upward direction, it means you are applying force in upward direction. So force has some direction. Either you apply a force rightward or leftward. Let's consider the example of a car as well. If you apply a force on your car, definitely the car will move in certain direction. So that's why we can say those quantities which have magnitude, unit, and direction. Definitely when you apply force, the force has some magnitude, unit, and later on the direction as well, which is upward, rightward, leftward, whatever that is. So those are vector quantities. These are vector quantities in fact. The vector quantities are represented by an arrowhead. In the figure, one end of that arrow is called tail, and the another end where the object is moving is called the head. And the length of that vector is actually the magnitude of that physical quantity. Suppose if we apply a 10 Newton force, so the magnitude of that quantity is 10. So this length represents the actually magnitude of that specific quantity, and the direction of arrow shows the direction of that vector quantity. Question is this: how we can represent a vector? Vector can be represented by different ways. One of them is vector can be represented by a boldface italic letter A, capital A, small a, or D, these are actually in boldface letters. These, whenever in we read in a book, vector quantity will be represented by a boldface letter. Another way of representation of a vector is by putting an arrowhead on the top of the vector quantity. Look at the second figure. That second figure shows a velocity. It is acted some way, and velocity represented by v, and we put an arrowhead at the top. This is another way how we can represent vectors. Now the term position. This is not the position in your class. I got the first position, I got the second position, I got the third position, and someone will have the last position in the class. This is actually the term related to physics. So the position is actually the location of a point or a place with respect to some reference is called position. For example, let's take we discuss about the figure on the right side. It's a rectangular block. Consider this is your room, and the small rectangle, blue rectangle, is actually the door of your room, and the circle is the position where you are sitting inside your room. And if I ask you, where are you sitting in your room? The answer will be, I am sitting on the right side of the door in my room. So when you are saying I am sitting on the right side of my room, it means you are telling me your position. You are describing me my position where you are sitting now. On the left side of the figure, which also describes the position. Look, so 0 is the origin, as we discussed. Door is some reference point or origin. Here, the pole, light pole, is actually the reference point. A person is on the right side. Let's suppose is at position 2, and its reference point is from that light pole, and person is on the another side, which is on negative x-axis side at -1. Its position is also with respect to that pole, because that is the reference point. You can also describe the position of any body with respect to some reference. If someone asks you, where is Carrefour, and you are on the road, and someone asks you, where is Carrefour, so you will describe the position of the Carrefour with respect to that specific position where you are standing now. So where you are standing at that point is actually the reference point. So with respect to that reference, you describe the position of Carrefour or Lulu, etc. Now the term distance and displacement. Distance and displacement. Now the term distance and displacement. Distance and displacement. Distance is actually the length or the path traveled by a moving object is called distance. And look at the figure. The curved path, if you start your motion from one point and moves to the other point. So the total path taken, the curved path taken by yourself, is actually the distance covered by you. So the total path, the total length traveled by a moving object is called distance. It has no direction. That's why it's a scalar quantity. It has magnitude only and units only. You know, the distance is the unit of distance is meter. It is represented by small d. It is represented by x as well. So it's a scalar quantity. Keep one thing in mind, and a body follow the curved path. Now let's discuss the displacement. So displacement is a distance in a straight line. Distance in a straight line with specific direction. So when we use the word a distance of a body in a straight line with specific direction, it means it's a vector quantity because it has specific direction. we can also define displacement as the shortest distance covered by object. Look at the dotted arrow. This dotted arrow is actually the shortest distance covered by an object. The curved path is actually the distance, and the dotted line, straight line, gives us about the shortest distance, and this shortest distance is called displacement. And look, it has some direction. That's why it's a vector quantity. Its unit is meter as well, because it's the shortest distance. When we use our distance, its unit is also meter. So displacement only addresses the overall change in position from one position to another position. Now let's discuss the distance and displacement in a different way. Through this example, we can easily understand about the distance of a body. If you start your motion from this point, and if I ask you in the example, your physics teacher walk 4 meters to the east, and then after that your physics teacher moves 2 meters towards south, then 4 meters towards west, and then again 2 meters towards north. So my question is, what is distance and what is displacement? So distance is the total path covered. As I told you, distance is total path covered. So initially your physics teacher covered 4 meters towards east, then 2 meters towards south, so 6 meters, again 4 meters towards west, 6 plus 4, 10 meters, and further 2 meters toward north. It means your physics teacher covered 12-meter distance. Okay, this is the distance. Question is, how much displacement he or she covered during this journey? As I told you, displacement is the shortest distance between 2 points. So you started from one position, and when you started from one position, I mean this position, and you again by covering this distance, and later on from this path, and again you reach at the same position. So there is no change in your position. You come at the same point again. So it means your displacement is 0. So the conclusion is, we covered some distance, but there is no displacement. This is how we can easily understand these two terms, distance and displacement. I hope you learn each and everything in a easily understand this thing in a better way. Thank you very much.